Here we're going to look at the topic of compound interest. This is driven by a formula, and that formula does have a lot of parts, but we're going to look at every one of those parts one at a time, make sure they make sense before we move on to using that formula to answer questions. Okay, there's our formula for compound interest. A equals P times 1 plus R over N raised to the NT. A lot of these terms you're already familiar with from working with simple interest, but let's go ahead and step through them anyway. This capital A over here on the left, that is going to represent our future value, which is the principal that we started with plus the interest that gets added on. So it's a little different than the formula for simple interest that just gave us the interest. Here, this formula gives us a future value, which is the principal and interest together. Kind of lets you know for sure that that P then is going to represent principal, just like it did in the formula for central interest. R is going to be the interest rate. Make sure that you convert that to a decimal before you plug it into the formula. T is still going to represent time, and time is always going to be expressed in terms of years. And there's one more new item in here that we got to take a look at, and that's this N. What does that N represent? And that is the number of compounds per year. That is, how many times does the interest get compounded in a year? So the number of compounds per year. And there are some key values that we're going to use for N. If our interest is compounded annually, then that means it's going to be compounded one time for a year, so N is going to equal 1. If our interest is compounded quarterly, then that means it's going to be compounded 4 times per year, and N is going to equal 4. And if our interest is going to be compounded monthly, then that means it's going to be compounded 12 times a year, so N is going to be 12. Those 3 values for N are the ones we're definitely going to use most often, so make sure you're comfortable with those. Now let's look at an example. Find the future value if $400 is invested at 3% compounded quarterly for 7 years. One of the things that often comes up is, how am I supposed to know if I'm going to use the simple interest formula or the compound interest formula? Well, the good news is the problem will tell you. We are told that this is invested at 3% compounded quarterly. So that's telling us right there that we need to use the formula for compound interest. And let's take a look at that just as a reminder. I have A equals P times 1 plus R over N raised to the NT. So what we need to do is figure out the values that are going to go in for each of those variables, plug them all in the right spots, and be real careful with our calculations. So let's start doing that. Future value is what I'm looking for. So I don't know what A is, so that's just going to stay A. Principal is how much I started with, how much I invested. Well, that was $400. 1 plus R, that's the interest rate. Remember, make sure you convert that to a decimal over N. That's that new thing. Okay, it's compounded quarterly, so that's 4 times a year, so N's going to be 4, and that's going to be a 4 in both spots. And T is time, and I'm told it's 7 years. So I've plugged everything into the right spots. Now I just have to simplify this. Remember, order of operations tells us parentheses, exponents, multiply and divide, add and subtract. So I need to start with whatever's inside the parentheses. So let's go ahead and do that next. And I have A equals 400 times 1 plus. Okay, I've got to do that division inside the parentheses, 0.03 divided by 4, my calculator gives me 0.0075. And I can go ahead and clean up that multiplication in the exponent right now and have the 28th power. Next, I've got to finish simplifying inside those parentheses. So I'll go ahead and do that, and I'll have that A equals 400 times 1.0075 raised to the 28th power. I'm still working on simplifying this thing, and let's take a little detour really quick right here. Where I'm at is A equals 400 times 1.0075 raised to the 28th power. So I'm done with everything inside the parentheses, so the next thing I've got to do is the exponent. And you might be thinking, well, how in the world am I going to raise something to the 28th power? My calculator doesn't have a button where I can raise something to the 28th power. Well, that's okay. If you look on your calculator, you might see a button with a symbol like that, that's called a caret, or you might see one that has a button that has y raised to the x power, or it could be x raised to the y power. We can use that button to raise any number to any power. So what we're going to do here is we're going to type in 1.0075. We are going to hit that y to the x button, which allows me to raise any number to any power. I want to raise this to the 28th power, and then I'll hit my equals key, and I've taken 1.0075 and I've raised it to the 28th power. And when I do that, what I get out is a really, really long decimal. On my calculator, it's 1.232711748. Your calculator might hold a little more decimals than that, or it might hold a couple less. We're not going to round that off. We're going to keep all those decimals. So I'm going to write down what I've got here, which is A equals 400 times the result of when I raised 1.0075 to the 28th power, which was 1.232711748. And the reason I'm keeping all those decimals is I want my answer to be as accurate as possible. So I'm not going to do any rounding until I get to the very end. On the bright side, I've got this 1.232711748 just kind of sitting there on my calculator. As long as I just leave it there, my next step is to multiply by 400. So I can just hit times 400 on my calculator, and I can see that A is going to be 493.084699. Again, keeping all my decimals. Now I've made it to the very end. This is the place where I'm going to round. And I want to round to the nearest cent, which is to the nearest hundredth place. And I look one space to the right and I have a 4, so I'm going to round down. So my answer here, find the future value under those conditions, and that will be $493.08. Make sure you plug the correct numbers in for the correct variables, and then just be very careful with your calculations.